Hi, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe how the reversals in Earth's magnetic field provide evidence for plate tectonics. Let's begin our discussion by establishing the fact that the Earth has a magnetic field. It's generated in the iron alloy of the Earth's core, but it penetrates through the mantle and the crust and wraps around the planet, leaving the South Pole and coming back into the North at the North Pole. This is important because this shape of the magnetic field ends up providing different conditions at different faces on the Earth. So if you were standing at the south magnetic pole, the magnetic field lines would be almost vertical, coming out of the Earth and pointing up. Whereas if you were standing at the equator, they'd be pretty much horizontal, parallel to the surface of the Earth. And if you were standing at the magnetic North Pole, they'd be pretty close to vertical again, but this time pointing down. This is important because certain rocks have magnetically susceptible minerals in them. So here we see a lava flow flowing along. On the Earth's surface, it's exposed to the Earth's magnetic field, and little magnetically susceptible minerals in that lava flow will align themselves with the Earth's magnetic field as long as the lava is liquid. Once it solidifies, they're locked in place, and geologists can collect a sample of that lava rock, take it back to the lab, and analyze which way those little fossil magnets are pointing. This allows the reconstruction of apparent polar wander paths for different batches of crust. So here on this map, we're looking at an apparent polar wander path for North America and one for Eurasia. So the way this is presented here, it's as if the continents cannot move. And if you go and you query North American rocks about where they were 500 million years ago, they say, well, the North Pole was here relative to us at that point. 400 million years ago, this is where the North Pole was relative to North America. 300 million years ago, it was here. 200 million years ago, 100 million years ago, and 0 million years ago, it happens to be at the North Magnetic Pole where it is today. Europe tells a very different story. If you go and ask Eurasian rocks, or their little magnetic minerals, where the North Pole was 500 million years ago, they give you a different answer.